Flat Earth expert Mark Sargent thinks the moon landing was a hoax.
Technically, the moon itself is a hoax. I could do this standing on my head.
Thanks, gravity.
Greetings, the Astro 30 here yet again with a brand new exciting episode of Astro's Electronics Lab. Now, today we're going to be looking at a simple transistor stereo preamp. Now, only one channel is shown here for simplicity, plus I don't need to test both channels at the same time. All I need to know is, does this circuit work at all? So that's why I'm going to test just a single channel. Now, looking at this, we've got the DC coming in here. It's going to be running at roughly 24 volt in the end. Goes through this 4K7 resistor and this decoupling capacitor bank here, these two capacitors, 100 microfarad and 100 nanofarad. That gives us a little bit of DC decoupling here. And if we go right over to the input, it's also DC decoupled again through this 1K5 and this 100 microfarad capacitor. Now the input comes in over here through a 10 microfarad non-polarized. All the 10 microfarads are non-polarized. Through this pot, which is our volume, we've got this 10K resistor here which does two things. First, it blocks any radio interference that might be on long cable runs at the input because the cables are acting like antennas. And it also goes into this balance pot, which when this is rotated one way or the other, brings this channel to ground. So in the case of this would be the clockwise position. We're looking at the left channel. As soon as this is rotated fully clockwise, we're now bringing this input to ground. So this 10K resistor also prevents, or helps prevent, the input being shorted out to ground. So it's actually putting a load across it. Now, it doesn't have to be 10K, it could be 1K. I might change it to 1K yet, but it doesn't really matter at this point in time. I just want to see if the circuit works. Now, past the balance control, we come into this transistor here, which is operating in class A. This is an emitter-follower. So it will produce no gain, however, it will allow us to take a high impedance input and drive a lower impedance output. And this tone control network over here is considered a low impedance load. And we've got our power coming off the collector here after the decoupling to go to the right channel, and over here after the 4K7 to go to the right channel on the other side. From the emitter we go into this standard backsandle circuit, which on the original schematic I got this from, I've actually changed it to this because it's much more less discombobulated. Got a base pot here, treble pot here, and the output is taken off of the center between the two. That then goes into this transistor here, which I did calculate between this resistor and this resistor. We're operating at a gain of roughly 25. However, if we notice, the output comes off the collector and is then going back to this side of the backsandle circuit. So if we were to look at this as if this was a op-amp based active backsandle circuit, this transistor is doing the same job as the op-amp does. It will basically boost its gain to whatever bass frequency is being boosted or whatever treble frequency is being boosted, and vice versa. That means the gain of this transistor is being controlled by this network, so for all intents and purposes this whole preamp may not actually produce any gain, although that's up to testing. So if we had like 600 millivolt going in, we'd probably only end up with 600 millivolt going out if it was 1 kilohertz. A preamp really should be producing at least 2 to 3 times the amount of gain. So if you had like 1 volt going in, you got 3 coming out, just so that the volume control is not spending most of its life at the halfway position to get any decent volume out of the amplifier. Again, this is up to testing. So what I'm going to do is I'm first going to build this input section and test it. And then I'll move on to this output section and I'll put all the components for the bass and treble network on the pots, like solder them to the pots, because it just makes it neater. That way I don't need 6 wires going into a breadboard, I only need 3, the input, the output and the feedback. And then we'll just test it as we go. So that's what I'm going to do now, is I'm going to assemble this stage, but I'm probably only going to have the 10K, the 10 microfarad. I'm going to omit the volume control and the balance control for this part of the test because it's not really necessary. So I'll put in this DC bypass and this DC bypass as well first, so they're both in there. But as I say, I'm going to build this transistor stage first, measure its output and see what we get. Alright, let's go. Okay, and a short time later I believe I've got it assembled, well, the single input transistor. I may have just enough space over here for the second one. I do have everything set up, power supply over there, oscillator, oscilloscope. I apologise in advance for this lead just in shot, but it's just how it went. So I'll turn it on. Ooh, we actually do have an output. We're currently getting 480 millivolts out. It's probably about 500 going in. It's going through a 10K resistor, so it will limit it a bit, but it seems to be tracking fine. So okay, where it's not producing any gain, which we wouldn't expect it would, we are seeing that it is working as a voltage follower. Now if I change my input connection from that side of the 10K resistor to that side, it's more like 510 millivolts, something like that. Might just change the scale. There we go. Yeah, it's not much of a loss. It's a little bit of a loss, but it's not actually technically a preamp yet. So if I move my oscilloscope probe to the input, it's about the same. So it's about 520 millivolt going in to about 480 coming out, which is perfectly fine. So now it'd be a good idea to build the other section of the preamp, if it's going to be a preamp. We'll soon find out the hard way. And if this doesn't work, it's still going to be uploaded as a video. I may be able to make it get some gain. I mean, I could change where this is being connected to the collector rather, but I would have to put a resistor in. Yeah, because this goes off to the right hand channel and you don't want both mixing with each other. However, that's irrelevant right now. I'm going to build up this back-handle circuit by soldering the components to the pots, and then just build up this little transistor stage here at the output on the other side of the breadboard, and we'll see if we have an output that's greater than what we're putting in. Okay, I've got the second transistor stage configured, got the back-handle circuit wired, and now we're ready to test. So you guys can look at the oscilloscope whilst I turn the power on. And we do have an output, but it's a heck of a lot less than what we're putting in. This is not working as an amplifier. Well, not very well. Now, see, the thing is, if I rotate my treble pot, we do get a slight increase and decrease, so I know the treble is working. So if I increase my frequency to a higher frequency and change my time base so we can see the waveform, and then rotate the treble pot, we get an increase and a cut, so that circuit's working. If I lower the frequency to, I don't know what that is, about 200 Hertz, do it so we can see it, then we rotate the bass pot, again we have an increase and a cut. So I can see that it's working, however, just not very well. So if I disconnect the feedback line from the back sandal circuit, and just leave it like that, we do have a higher output. We're putting out more like 1.2. And what we're on bass, aren't we? So I'll just decrease that even further. Nope, that was too far. Try that instead. So yes, it is boosting and cutting. So I know that the bass, well, doesn't seem to decrease much. So we're back at 1 kilohertz, and yeah, it is increasing. But if I increase our input a little, we can see that it's flat bottoming a bit too early. That's because there's no negative feedback now. So what I'm going to try is I'm going to try putting a 100k resistor from here, the base, to ground, and hopefully that'll help correct that flat bottoming. Okay, so adding a 100k resistor between the base and ground made absolutely no difference. However, I changed this 150k resistor here to a 470k, and I was able to get a little bit more voltage out of it peak to peak before it asymmetrically clips. So that's not too bad. So it starts to asymmetrically clip there. So about roughly 3 volt peak to peak, which is, I reckon I'm putting about 600 millivolt in. So if we do the calculation, well, it probably would be a good idea to actually measure what's going into it, just so we know. Okay, I'm going to say around about the 550 millivolt mark. So if we take our voltage out, which is roughly 3 volt, and we divide that by 0.55, that gives us a gain roughly of 5.4, which is, yeah, okay, that's not too bad. So what would be a good idea now is to hook this up to the power amp that it's going to be powering, which is that 15 watt power amp that's on the other breadboard. Put a volume control obviously in front of this circuitry here so we're not overdriving everything, and just see if it pickles it nicely and, you know, doesn't distort, doesn't make any weird unusual noises, etc. Well, I've got it hooked up. There's no unusual noises. However, I did find that the bass and treble controls will not work properly without the feedback, negative feedback loop in there. However, the power amplifier itself has a gain of roughly 72, so it will, for all intents and purposes, provide enough gain. And we have got noise, but that's because the connections are shit. So anyway, I'll play a track. There we go. Treble. Bass. Brilliant. Alright, now obviously this circuit is really designed for a power amplifier that has a relatively high gain. So if you connected it up to an amplifier that had a gain of say 23 for instance, it's not going to give you much output. You could probably modify the circuit a little bit further. You could probably add an extra transistor on the output to just boost the output up a little bit. But I'm not going to do that because the whole entire purpose of this preamplifier, if you want to call it that, is to give bass, treble control, balance and volume. And but basically that's it. It's not really there to provide any extra gain. As I say, that power amp is working at a rough input of 400 millivolt for its full output, so there should be more than enough output from that little circuit there off on the left to drive this to pretty loud volumes, and as we can hear, it is driving it pretty hard. That being said, I'm going to clean up now, pack things away, and then I'll just finalize this video. Okay, so here's the schematic again for reference. The only change I have made is changing this 150k resistor to a 470. It seems to be okay. That's 470k, that by the way. You may be asking yourself, well, what is the point of a preamplifier that doesn't output much gain than what you put in? Well, as I said, that power amplifier I'm going to be powering into from this is designed with a gain of already 72, so it only requires 400 millivolt to go in to get our full 15 watt output. All the job of this is to take our high impedance input source from whatever it is, a tape deck, CD player, laptop, computer, whatever, bring it down to a lower impedance, control the bass and treble, and buffer the output into the power amp, because technically speaking the power amp is the one producing all the gain. So you could, this originally was designed using 2SC945 transistors, and I've changed them to BC547s. If you use the original 2SC945s, you may end up with slightly higher gain at the output, because well, the 945 is actually a high gain transistor and is used in a lot of Japanese amplifiers and Chinese knockoff amplifiers and whatnot, and they're still used now. I just don't have any, so that's the reason why I'm using BC547s. This is open to you to experiment, but I'm happy with how this performs for my purpose. Now, I will make a PCB for this. All the input switching and stuff will be on PCB as well, so that's way in the future. We're talking a couple of months here yet before I get that far, because I'm working on that 15 plus 15 watt amplifier, and I thought, well, I do want to control the volume and also the bass and treble. It'll be a lot less noisier on a PCB with proper shielded cables going between the preamp and the power amps. And you won't get that buzz there as you were getting in the sound test there. That's only because it's all exposed wiring and there was jumper leads going everywhere. But yeah, again, this circuit will not work without that negative feedback line in there. But anyway, I'm going to leave this video here, and if you enjoyed it, please remember to rate, comment and subscribe below, and you can always follow me on Facebook or become a Patreon member for as little as $1 per month. Anyways, this is Yastro30 saying see ya. Have a great day. See you in the next one. Hopefully the next one will be something to do with the 15 plus 15 watt amplifier project. Well, this is part of it, but yeah, anyway. Alright, I'm just rambling at this point. See you later.